Hello, good morning. My name is Emian Mon. In this video, I will explain my solution for abalone dataset assignment covering question number one. The objective is to classify abalones into abalone dataset into male, female, or infant category using the natural number while demonstrating overfitting, model improvement, and model visualization. First of all, I load the abalone dataset using Pandat, assign the column name based on the UCI dataset descriptions. So after I load the data, I'm trying to be printing how many row that in this data set include. So the row is total 4,177. So it is I'm trying to be retrieve the dot and the 20 row for the reference. And after that, I'm trying to be count how many value for the if category like the male, infant, and then female. And then I'm trying to be split data into the 50% training and 50% validation set using the trainings test spread from the circuit lens. The separation is allowing the model to be trained on one portion of the data evaluate on the MSIN's samples, helping to detect the overfittings. So here is the result for the training rule and then validation rule. I'm trying to be printed out all of the data. So the caution number B is we are trying to be uh, train on the poor deep natural network using the Garrett Morris segregator to classify abalone into male, female, or infants. Uh, so firstly, I'm trying to be separate age feature and then one features. Uh, So I'm trying to be print out the oral the result. And then in this data set, they mention that the value is a M, F, and I. But for the assignment question requirement, they is mentioned that the female, female, and then infants. So I'm trying to be changed for the requirements names from the MFIM. So all of the MFIMs the column the MSI value are changed to the male, female, and then infants. So this one is I'm trying to be make the convert class name to the integer. So natural network need the numeric level for the training because natural network cannot be trained directly onto that test level. That is the reason that I am trying to be encode here. So to internationally overfit the data and encode the categorize the set level into numerous values, get the input feature using the standard scalar and then bit the lot natural network using the correct Morse sequence with the many many decent layer and non-regulation. So the model is trained for the 100 response. So training, validation, loss, and accurate are plotted and says at the Avalon B BMG to clear show the overfitting behavior. So you maybe see that that is the I create the valuable name to the poor model and and then trying to be combined. So that is the poor model summary. And then this here is a trying to be trained to the 100 elbows. So it is the model training here. And after that, I'm trying to be create the figures to show in the data over there. So after that, for the question number C, is required to be improve the natural network. So the model is improved by the reducing network size, adding back normalization to regulations and draw up layer. So I also trying to be change the activation function kernel initializer, optimizer, and then apply learning rate schedule. The improved model is trained for the 100 outposts. The performance metric are plot and state abalone C, BMG showing improved the generalizations. So here is first of all the learning rate schedule slowly reduce the learning rate during the trainings. So this have to the optimizer mid big step earlier and then smaller step later, often improving stability and validations performance. So I use optimizer for the events because it's time to it's use the less is use and then is use the on top variable large schedules large scales instead of fit the learning rate. Then I'm trying to be improve the model from here. So in this model, I'm trying to be the he normal initializer work well with the ReLU and ELU types activations. So I'm trying to use the smaller network to reduce the overfitting. Just now I mentioned, and then adding the normalizations to stabilize the speed of training and applying the do regulations to the penalize the lot weight and draw out the prevent the model to rely specify neural. So this one is I'm trying to be referent on the Geron's the dashboards. So and after that is coming out the model summary, and then I'm trying to be combine that this model and trying to be trained on the 100 earphones from here, and then create the figure and then save the avalon.c png as per the Gaussian requirements. So for the Gaussian lemma D is generate the model visualizations. So I'm using the window Jupyter so that I'm trying to be install this application download directly download from the this location grab wave and then I'm trying to be install it and in order to uh, uh, run this in order to do this assignment caution D. So you maybe see that I may need to be install this requirements, the graduates, and also the install to plot dot in order to create uh the model visualizations pictures. So I visualize both model using the carrot util plot models. So the poor model is it as the abalone DBBMG, and improved model is safe as the abalone DCPMG. So this diagram show each layer and then data flow, allowing the right comparison and then more complexity. So this one is the first pool model. I'm trying to be safe over here. Is named so-called the Avalon uh, DB. But I would like to see the image so that I'm trying to be display inside the my inside the Jupyter notebook as well. So this one is it is the good model. So I'm trying to be plot the model and then trying to be print out with and then save up the avalon dc.pmg and then display the file name the avalon dc.pmg. So all the data processing, model construction, and then training plot for visualization code were written by me. But the general technique approved were adapted from the lecture note, Jerome dashboard, and then data flow, and then carrot documentation, and the skip lamp documentations. But I use the ChatGPT and Gemini for the some of the code debating and the classification support only. That's all for my assignment.